Start करूं? Good afternoon to everyone. My name is Ashish Kumar Singh, working as assistant professor in applied science department in IMT group of college, Greater Noida. Today I am going to present topic lecture on DC machine and its classification. So before going to discuss DC machine, first we have to know what is electrical machine. When we are talking about electrical machine, so electrical machine is a electromechanical energy converting device which converts either electrical energy into mechanical energy or mechanical energy into electrical energy. Depending upon the conversion, it will be classified as motor or generator. So here we discuss about DC machine, that whether it is either take DC electrical energy to convert it into mechanical energy, or it generate DC electrical energy. When we are talking about construction of DC machine, as seen here in picture, the construction of DC machine, here we have commutator, armature winding, armature, gap, brushes, frame, stator and stator winding. Apart from it, when we are talking about construction broadly, DC machine mainly consists of two parts, stator and rotor. The stationary part of electrical machine is known as stator, while the rotating part of DC machine is known as rotor. Rotor is also known as armature. When we are talking about stator of DC machine mainly consists of two main parts, field magnets and brushes, while rotor of DC machine consists of armature and commutator. When we are talking about field magnet comprises of three main parts, that is yoke, pole, pole shoes, and field coils. Here, here in picture, we saw the figure of stator. It consists of frame, that is outer part of machine is known as yoke. Yoke is the outer part of DC machine, that is called yoke. It is used to provide mechanical protection to the machine, and it also provide return path for the flux. So it is made up of low reluctance magnetic material, mainly cast iron or silicon steels. When we are talking about poles, poles are mounted on an iron core and used to carry insulated field coils, and pole shoes are used to provide support to the field winding, as well as it spread magnetic flux inside air gap uniformly. And its third parts is field coil. Field coil is also known as field winding. Field coil is a winding wound on the poles is known as field winding. It is energized by external DC source, and it is made up of copper and aluminum. When DC current passes through the coil, it will generate EMF and it will magnetize the pole and produce magnetic flux, and magnetic pole shoes spread this magnetic flux inside the air gap. Brushes. The brushes are used to collect current from the commutator, carry current from the armature conductor. Brushes are made up of carbon. The brushes are held to the surface of the commutator by the spring. Now, other part that is known as rotating part of DC machine is known as rotor. When we are talking about the rotor, rotor consists of armature, armature winding, and commutator. Armature, what is armature? Basically, the other name of rotor is armature. It is a rotating part of a DC machine. The purpose of armature is to rotate the conductor in the magnetic field so that electromechanical energy conversion can take place on the armature winding. The armature winding is placed on the slots of the armature core, that is cut on the outside of the outer periphery of armature. The armature winding links with the magnetic flux when armature are rotated and induce a rotating magnetic flux. Actually, electromechanical energy conversion takes place on armature winding. Now, the most important part of DC machine is a commutator. Why it is important? Because as we know that the EMF induced on armature winding is always alternating. So here commutator convert this alternating uh, electromagnetic EMF into DC, direct current. It is also known as a mechanical rectifier. When you are talking about the commutator is mounted on the shaft of a machine. It is used to connect a stationary external circuit to the rotating armature conductor. It is made up of number of segments of hard-drawn copper. All segments are insulated from each other by thin layer of mica. Why it is made up of hard-drawn copper? So that minimize wear and tear takes place during movement context between commutator and brushes. So this is the pictorial representation of rotor or armature. Here we see here this is a armature, or you can that rotor, where armature conductor are housed, and this is the commutator segment where armature conductor are connected, and carbon brushes are placed here placed here with the help of spring, so that it can collect current from commutator and supply to the external circuit. And there is other also parts, that is shaft, bearings, etc. Working principle of DC generator. What is the working principle of DC generator? When we are talking about the working principle of DC generator, it works on the principle of Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? When conductor moves in a magnetic field, it cuts magnetic line of forces due to which an EMF is induced on the conductor. This is called Faraday's law of electromagnetic induction. This electromagnetic induces due to two reasons. One is static induced EMF, second one is dynamic induced EMF. If EMF induced due to the movement of conductor, then it is known as dynamically induced EMF. And if EMF is induced due to the alternating magnetic flux links with the stationary conductor, then it will known as a static induced EMF. On static induced EMF, transformer works, while electrical machines works on the dynamically induced EMF. When we are talking about the working principle, whenever a conductor is moved in the magnetic field and it cuts magnetic lines of forces due to which an EMF is induced in the conductor, and the magnitude of induced EMF is directly proportional to the rate of change of flux. While we are talking about its mathematical expression, induced EMF is equals to BL sine theta, where B is the magnetic flux density, L is the length of the conductor, V is the velocity of conductor, and theta is the angle between magnetic line of forces and movement of conductor. This EMF causes a current flow if the conductor circuit is closed. When we are talking about the working principle of DC motor, here it works on the principle of Faraday's of electromagnetic induction, and the working principle is that when a current carrying conductor is placed inside a magnetic field, uh, current carrying conductor induces its own magnetic field, and due to the interaction of magnetic field and current carrying conductor field, a force is generated due to which conductor starts rotates, and the magnitude of force is given by the formula BIL sine theta, where B is again flux density, L is the length of the conductor, and I is the magnitude of current passing through the conductor coils. While the working principle, the direction of current induced or the direction of force produced on motor is given by Fleming's rules. While Fleming left-hand rule is applicable for DC motors, or we can say that motors, and Fleming right-hand rule is applicable is applied for calculating the current induced in generator. What is Fleming left-hand rule? When Fleming states that we when we stretch our three fingers in a such a way that it is mutually perpendicular to each other, the thumb represents the direction of motion, or we can say that thrust force, and middle finger tells about the current, and four fingers tells about magnetic field, as seen here in the diagram. While we are classification of DC machine, DC machine can be classified into DC generator or motor, depending upon whether it can produce electric current or it can produce mechanical energy. Further, DC generator or DC motor is further classified into two categories, that is self-excited DC generator or DC motor and separately excited DC motor. In self-excited or separately excited DC motor, in separately excited DC motor, we provide autonomous DC source for exciting field winding. While in case of self-excited, a residual magnetism will use to produce magnetic field initially, and then magnetic field build up, and this machines works. While talking about self-excited DC machine, self-excited DC machine is further classified into three parts, that is series generator, shunt generator, and compound generator. The name based upon whether field winding is connected in series with armature circuit or parallel with armature circuit. If field winding is connected in series with armature circuit, then this type of machines or generator is known as series generator. While if field winding is connected parallel to the armature circuit, it is known as shunt generator. In compound generator, series and shunt field winding both are placed in series or parallel with armature circuit. Depending upon the connection, if shunt field winding is connected in parallel with series field winding and armature circuit, then that type of connection is known as long shunt compound generator. Or if shunt field winding is connected in parallel with only armature circuit, then that type of generator or motor is known as short shunt compound generator. This is the circuit diagram of separately excited DC generator. Here we can see here field winding is separately excited by DC source, due to which a magnetic field is created, and when an armature is rotated with the help of prime mover, this armature conductor cuts magnetic line of forces, due to which an EMF is generated across the armature, that is represented by EG, and when load is connected across the terminal, a current starts flowing from armature, that is IL, and it goes towards load current. Then when while we are talking about self-excited DC generator, first one is series generator. As I said that in series generator, series field winding is connected in series with armature winding. So if load is connected, generated a current start flowing from armature current, and it goes through series field winding. So in this circuit, as we know that in series current will be same, so armature current will equals to series field winding current is equals to the load current. We can say that it is I, and the voltage across the load, that is V, is equals to EG minus IARA drop, that is the drop due to the armature winding resistance voltage drop, and RSI into RSC, that is the voltage drop across series field winding. And power generated across the load is equals to the Eg into Ia. So here this is the circuit diagram of DC shunt generator. Here we see clearly that field winding is connected in parallel with armature circuit, and a part of uh, armature current that is generated at armature circuit is going through shunt field winding that will help to build magnetic field. So here the armature current is equals to the current flowing through load and current flowing through the shunt field winding. The shunt field current is always equals to V upon RSH. As we know that voltage, terminal voltage is constant and shunt field resistance is constant. So current drawn by the shunt field winding is always constant. Voltage across the load is equals to the V equals to generated EMF minus voltage drop across armature winding, that is called minus IARA. So net voltage we can calculate using this formula Eg minus IARA. Power generated at armature is equals to the, as we know that the formula for power is V into I, and the generated voltage is Eg and current drawn supplied by the armature is Ia. So power generated at armature is equals to Eg into Ia, while power delivered to the load is equals to the V into IL. When we are talking about DC compound motor, this is the connection of short shunt compound motor. Here we clearly see that shunt field winding is only connected in parallel with armature circuit, and a part of armature current is going to shunt field winding and rest amount of armature current is going through series field winding to the load. So here armature current is equals to the sum of load current plus sum of current flowing through the shunt field winding. So Ia is equals to ISH plus IL. While the value of ISH we can calculate either using formula Eg upon Eg minus IARA upon RSH, or we can say that V voltage across load plus voltage drop across series field winding divided by RSH. Voltage across load we can easily calculate by using formula generated voltage minus voltage drop across armature winding, that is IARA drop, and minus voltage drop across series field winding, that is minus ISC RSC. So power generated at armature is equals to Eg into Ia, while power delivered to the load is equals to voltage in V into IL. Next is long shunt compound DC generator. Here shunt field winding is connected in series in parallel with series combination of armature circuit and series field winding. So generated current is directly going through series field winding. After series field winding, it splits into two parts. One part of current is going towards field winding to excite shunt field winding, while other part is going towards load to deliver electrical energy. So here the shunt field winding current can be calculated using formula V upon RSH. Armature current Ia is equals to series field current. So ISC is equals to Ia and Ia equals to IL plus ISS. Voltage across the load is equals to the generated EMF across armature minus voltage drop across armature winding, that is IARA, minus voltage drop across series field winding, that is ISC into RSC. As we know that in series circuit current is same, so Ia equals to ISC, so we can write it as a Eg minus Ia within bracket Ra plus RSC. Power generated at armature is equals to Eg into Ia, that is generated EMF across armature circuit into armature current, and the voltage current electrical power delivered to the load is given by formula V into IL. This is the classification of compound motor according to connection. While according to the excitation, we can classify DC compound generator into two categories, that is cumulative compound and differential compound generator. While here, as name suggests, cumulative, it is made up of accumulation. So in cumulative compound motor, flux produced by series field winding and shunt field winding is in same direction. So net flux is equals to the sum of series field winding flux and shunt field winding flux. So it is known as a cumulative compound generator. While in differential compound motor generator, the flux produced by series field winding and shunt field winding are opposite to each other. So net flux is equals to the difference of flux produced by shunt field winding minus flux produced by series field winding. So in differential compound generator, net flux produced by the generator is reduced. Now we talk about application where shunt generators, series generators are used. Shunt generator is mainly used in electroplating, for battery recharging, and exciter for AC generator to excite field winding in case of AC generators are alternator. While the application of series generator can be used as a booster, as light arc lamps. When we are talking about motor, the application of shunt motor, as we seen previously, that the flux produced by shunt motor is constant. So net is shunt motor is used where constant speed is required and starting torque is not a barrier, because shunt motor produce low starting torque. So shunt motor is used for blowers and fans. It is used in centrifugal and reciprocating pumps, lathe machines, milling machines, and drilling machine. While series motor is used in cranes, hoist, conveyors, trolley, electric locomotive. Why it is used in cranes or electric locomotive? Because it produces high starting torques. But its disadvantage is its speed is variable. It does not produce constant speed. So if we require high starting torque and constant speed, so we can't use series motor or shunt motor. We use cumulative compound motor, and its application is rolling mills, punches, shears, and elevators. Thanks. That's it from today's lecture. Have a nice day.